Now that we've done our introductions, let's get right into our topic, which is compound interest. What is compound interest, you may ask? Well, in short, compound interest is the interest calculated on the principal and the interest accumulated over the previous period. In other words, the interest is calculated more than once during the term of the loan or investment, and this interest is added to the principal. This sum, which is the initial principal, and its interest then becomes the principal for the next calculation of interest, and interest is charged on this new amount, which is why compound interest is often referred to as earned interest on your interest. You may see the formula for compound interest on the slide, which is S equals to P multiplied by 1 plus I to the power of N. You can also calculate the interest earned by subtracting P from S. Now let me explain about the key compartments to the compound interest formula. S refers to the future value. P is the principal, which is our initial investment or loan. I is the interest rate per interval, which you can get by dividing K and M, where K is the annual interest rate, which you would convert to its decimal form, and the M is the number of times interest is compounded per year. N is the number of times interest is compounded throughout the term, which you can get by multiplying M and T, where T is the time the money is invested or borrowed for in years. Now let me talk about the frequency conversion for M. Number 1 is annually, which is once a year. Your M would be 1. Number 2, semi-annually, which is every 6 months. M would be 2. Number 3, quarterly, which is every 3 months. M would be 4. And number 4, monthly, which is every month. Your M would be 12.
And now I'm going to talk about annuity. So what is annuity? Annuity refers to a periodic payment of investment made at regular interval that is paid periodically over a specific period of time. Annuity assists us in making better informed decisions about our financial planning and investing needs. For example, house rent, mortgage payment, installment payment on automobile, and etc. There are two types of annuity, which is ordinary annuity, which payment that are made at the end of each interval, and annuity due, which is payment that are made at the beginning of each interval. Annuity has two formula, which is future value and also present value. For future value, we use S equals to R1 plus I to the power of N minus 1 divided by I. Future value we use to estimate how much an annuity will be worth in the future. For present value, we use A equals to R1 minus 1 plus I to the power of negative N divided by I. Present value used to calculate the current amount of money needed to generate a stream of future payment.
Question 1. Sunjay has a piece of land with a market value 110,000 ringgit. He has two options: to sell land now and invest a scam which offers an interest of 4.8% compounded monthly, or to sell after 3 years at 125,000 ringgit. What would like I advise to Sunjay? So now we're gonna calculate the amount of interest that he might earn if he sell the land now and invest a scheme. So this is one of the formula. S is the amount of interest that he might earn, and P is the principal, and K is the interest rate, which is 4.8%, and we need to simplify, which is 0.048. M is the amount of compounded in a years, and T is a years. So right now we're going to replace all of the numbers into the formula. So the last answer is 127,000 ringgit 77 cents. I would advise to Sunjay to sell the land now and invest a scheme, as he can gain more profit, which is 127,000 ringgit 77 cents, rather than just selling it after 3 years for 125,000 ringgit.
Question 2. Soy deposits 780 ringgit into an account that pays an interest of 9% compound quarterly. 3 years and 9 months later, she made another deposit into the account. What is the value of the second deposit if she wants the account to be worth 2,600 ringgit 2 years after the second deposit? For first deposit, P1 equal to 780, K equal to 0.09, M equal to 4, T1 equal to 3.75, and 1 equal to 15. For second deposit, P2 to be fine, K equal to 0.09, M equal to 4, T2 equal to 2, and 2 equal to 8. For first deposit, the formula used is compound interest. S equal to P times 1 plus I to the power of point N. S1 equal to 780 ringgit times 1 plus 0.09 divided by 4 to the power of 0.15. S1 equal to 1,089 ringgit 0.4 cent. For second deposit, S2 equal to S1 plus P times 1 plus K divided by M to the power of point N. RM 2,600 ringgit equal to 1,089 ringgit 4 cent plus P times 1 plus 0.09 divided by 4 to the power of 0.8. RM 2,176 ringgit 4 cent equal to RM 1,089 ringgit 0.4 cent plus P. P equal to 1,087 ringgit.
Question 3. Lisa invests 25,000 into an account at interest rate of K% compounded every 2 months. After 4 years, the account balance is 34,355 and 47 cents. Determine the interest rate K% compounded every 2 months. For this question, we use compound interest formula, which is S equals to P1 plus I to the power of N. To find the interest rate, we use K over M equals to S over P to the power of 1 over N minus 1. So K over 6 equals to 34,355 and 47 cents divided by 25,000 to the power of 1 over 24 minus 1. K equals to 0.08, which is K equals to 8%.
Alright, so right now we're gonna calculate the total amount if the investment was extended for another 3 years. So we're gonna use this formula. S is the amount of interest earned in 4 years, which is 34,355 ringgit 47 sen. And P is the principal, which is 25,000 ringgit. And K is the interest rate, which is 8%. And right now we're gonna simplify, and the amount of interest rate is 0.08. And M is the amount of compounded in a years, which is 6. And T is years. And right now we're gonna add 3 years. So we're gonna replace all of the numbers into the formula, and the last answer is 43,605 ringgit 15 sen. So we're gonna calculate the total interest earned for 7 years. The formula to calculate the total interest earned for 7 years is S minus P. S is the total amount of interest earned, and P is a principal. And the last answer is 18,605 ringgit 15 sen, and that was the interest earned in 7 years.
Question 4. Mr. Father trade his car for 35,000 ringgit and top up it up with his saving of 3,000 ringgit to buy a new car. The new car is listed at 88,000 ringgit. He obtained a loan from a finance company to settle the balance of the purchase price. He has agreed to settle the loan by monthly payment to be made at the end of each month for 9 years. The interest of the loan is 50% compound monthly. A. Find the monthly payment. First, we need to calculate total pay. 35,000 ringgit plus 3,000 ringgit equal to 38,000 ringgit. Next, we need to calculate total borrow. 38,000 ringgit minus 38,000 ringgit equal to 50,000 ringgit. Let's highlight the important point. A equal to 50,000 ringgit, R to be defined, K equal to 0.15, M equal to 12, T equal to 9, N equal to 108. This question uses formula present value annuity. A equal to R, 1 minus times 1 plus I to the power of point negative N divided by I. 50,000 ringgit equal to R, 1 minus times 1 plus 0.15 divided by 12 to the power of point negative 108 divided by 0.15 divided by 12. R equal to 846 ringgit 22 sen. Question 4b. Calculate the interest charge. The formula is I equal to NR minus A. I equal to 108 ringgit times 846 ringgit 22 sen minus 50,000 ringgit. I equal to 41,000. Question 4. B. Calculate the interest charge. The formula is I equal to NR minus A. I equal to 108 times 846 ringgit 22 sen minus 50,000 ringgit. I equal to 41,391 ringgit 76 sen.
Moving on to question 4C. Immediately after paying the 80th payment, he decided to settle the balance of the loan. Find the balance. Now, the question wants us to find the balance of the loan after he has made 80 payments out of the total 108 payments. We need to understand that after 80 payments, there are remaining of 28 payments on the loan, since 108 minus 80 is 28. To calculate how much is still owed after 80 payments, we use the formula for the remaining balance of the loan. This formula is AN equals to R multiplied by 1 minus open bracket 1 plus I to the power of negative N divided by I. All that's left to do now is to substitute the values into the formula. R would be 846 ringgit 22 cents. I is the monthly interest, which we can get by dividing 0.15 and 12. N is the number of payments remaining we have calculated earlier, which is 28. Once we have plugged in these values into the formula and performed the calculations, we find that the remaining balance after 80 payments is 19,888 ringgit 30 cents.
Question 5. A factory paid a 16% down payment to buy a machine that costs RM 135,000. The factory will pay RM 10,000 at the end of each 6 months to repay the balance of the purchase price. The interest charge is 16% compounded semi-annually. Find the number of years needed for the balance to be paid in full. So down payment equals to 0.16 times 135,000 equals to 21,600. Loan equals to 135,000 minus 21,600 equals to 113,400. This question used present value formula, which is A equals to R times 1 minus 1 plus I to the power of negative N divided by I. So 113,400 equals to 10,000 times 1 minus 1 plus 0.8 to the power of negative N divided by 0.8. 113,400 times 0.08 divided by 10,000 equals to 1 minus 1 plus 0.08 to the power of negative N. So negative N equals to negative log 1 minus 113,400 times 0.08 divided by 0.08 over log 1 plus 0.08. N equals to 30.89, also equivalent to 2 times T equals to 30.89. T equals to 30.89 divided by 2. T equals to 15.44 years.